Okay, this problem is for the most part geometry and algebra. That's the math behind it, but it's really a word problem, analyzing the text, understanding the graphic, and then being able to manipulate fractions is essential too. And then I want to show you how you could use logic and estimating to answer this question if you couldn't figure out how to do the actual math. So there's really not, again, a whole lot to review in terms of principles and concepts. So let's just go in and answer the question. All right, here's what we're told. First of all, the square below. That's important. It's a square. That means this dimension and this dimension are equal, and so is that dimension. All sides are equal. That tells us something important, and we need to remember that. And it's divided into 3 rows of equal area. That also tells us something really important, that the area of, let's just call this row 1, row 2, and row 3, the areas of those rows are equal. So if they're equal, what is the area of each row? It's 1/3 of the total, right? So row 3, row 2, row 1, each one is 1/3 of the total area. And then we get some more information. In the top row, that's row number 1, we've labeled it row number 1. The region labeled A has the same area as the region labeled B. Well, if they have the same area, this A and B are the same, we know that they are each 1/2 of the 1/3 total, or 1/6 of the total. So we know both those things. It's 1/2 of row 1, and row 1 is 1/3 of the total, so B is 1/6 of the total. So keep all those things straight. And then we're told in the middle row, the 3 regions have equal areas. So we know there are 3 regions. We know that the total area of row 2 is 1/3 of the total. And we know that this A is 1/3 of that 1/3. So we know that A in this row right here represents 1/9 of the total. It represents 1/3 of this row, and that row represents 1/3 of the total. So this is also 1/9, and this is 1/9. And then we're told in the bottom row, the 4 regions have equal areas. So now, bottom row is divided into fourths, and those areas are equal. So we know that row 3 is 1/3 of the total, and each of these little boxes inside of row 3 are 1/4 of that 1/3. So they represent 1/12 of the total. Each one of these boxes is 1/12 of the total. So we know we have 1/6, 1/9, and 1/12. And if we wanted to, we could go through and add this all up just to make sure. This would be 2/6. 2/6 is the same as 1/3, so that works. 1/9, 1/9 plus 1/9 plus 1/9 is 3/9, which is 1/3. 1/12, 1/12, 1/12, 1/12 is 4/12, which is also 1/3. So we've done our math right. And then the call of the question is, what fraction of the square's area is in a region labeled A? So we need to look at each of the areas that are labeled A. So it's these 3 boxes, these 3 rectangles. Well, we know that row 1, column 1, A, is 1/6 of the total. We know that this box labeled A is 1/9 of the total. and we know that this box labeled A is 1/12 of the total. So if we were to add all those up, we would know what the total area of boxes labeled A actually is. So now we get to our manipulating fractions part of it. How do you add fractions that have dissimilar denominators? Well, you have to get them into a common denominator form, and to do that you have to figure out what multiples are, and usually you start with the biggest one because it can't be part of a smaller one. So 12s, 6 would work, but 9 is not a multiple of 12. We go to the next, double 12 to 24, 6 would work again, but 9 is not a multiple. And you go to 36, and that works. So we know that 36 will be in our denominator. So that's 36, 36, and 36. 6 times 6 is 36, so we have to multiply the top by 36. So 1/6 is the same as 6/36. 1/9, we had to multiply that times 4, 9 by 4 to get to 36, so we got to multiply the top by 4. So 4/36 is the same as 1/9. And then 1/12, we had to multiply the 12 by 3 to get to 36, so we multiply the top by 3. So 1/12 is the same as 3/36. And now we just add the numerators. 6 plus 4 is 10, plus 3 is 13. So we have 13 over 36, and that is our answer. And you can see right here, answer K. Now, that's the math way to do it. And if you saw it right off, it actually would pop out, and it's not all that time consuming or difficult. But I wanted to show you another way using logic and estimating that would also work, but you would only use this if you were struggling with it and you couldn't figure out the math way of answering this. And this is just to show you how there's so many different ways to address these problems. And even though they tell you that figures are not to scale, they are roughly to scale. And by roughly, I mean they're really close. They just don't want to be held liable if they were off by some little tiny fraction. So they just tell you they're not to scale, but they're close. They don't try and mess you up by giving you something that's wildly out of scale. So knowing that, if we couldn't figure out the math way to do this, and we were just looking at these sections of A's that we need to add together to figure out what is the area that they make up out of the total, well, here's a way to do it. You could easily look at this A, and then these A, B, C's down here in the middle row, they are equal. So this C is the same as this A. So if you just brought that line up, you know that this box right here is actually this area right there, right? And now you know that this bottom row was divided into 4s, and so there was a middle line right down the middle here. So this line right here is the same as this line here that divided the A and B on the top. And this C box in the bottom row is the same dimension as this A. So we can move, if we just slid this up, we can tell that this is our remainder right here. So what do we know now? We know that adding this A plus this A, because it's the same as A, plus this A, because it's the same as A, gives us a row of 1/3 of the total, plus this sliver right here that looks like it might be like 1/3 of a quarter. Remember, these are a quarter each, and they're a quarter of a third, so they're 1/12. But if you couldn't figure out that math, you know that it's a little bit more than a third plus a little. And that little looks like it might be like a third of a quarter of one of these. But you don't know what it is. You know that you've got a full 1/3. You know that you have this full 1/3 area if you were to add them all together plus a little. Now that may or may not help you, but in this case it actually does. So if you just went back up to the answer choices with that little bit of knowledge, you would know that you're looking for 1/3 plus a little. Well, 1/9 is way less than 1/3, so you can eliminate that. 3/9, which is close, but 3/9 equals 1/3. We know it's a third plus a little, so we can eliminate that. 6/9 is the same as 2/3, which is double, almost double what we're looking for, so it can't be that. 13/12 is more than the total. It's 1/12 more than the total, so I don't know how they... Hopefully you didn't choose that one, but that's what that answer choice means, is it's 1/12 more than the total. So obviously that can't be it. And now we're left with this. Even if we didn't understand 13/36, it's the only answer choice that's left, but we should be able to do the math and have it work out. 13/36 is equal to, if it's 12/36, it's 1/3, right? 12/36 equals 1/3. That's the same. And so now we know that 13/36 is 1/3 plus a little, and that little was 1/36 of the total, which definitely I think would qualify as a little. So now we're at 1/3 plus a little. Like I said, you would only use this if you were unable to approach it in the math way and you were stuck. Just always remember that you can step back and address this from a different angle. Always keep that in mind. Just there's lots of tools that you have, and estimating is one of the tools in your toolbox, and you should use it if it's necessary. Use it. These questions have an answer, and that answer is A, B, C, D, or E, and they don't care how you got there. If you get the right answer, it's worth a full point on the exam just as much as somebody who sat down and wrote out the math and got it all right. If you can go on and estimate it or back solve it or plug in a test answer choice or use some other method, it's still worth full marks. Okay? Just wanted to point that out.